of databases. So, talk a little background here. What have we done in the past? It seems like most people have used SQL with LabVIEW at some point. And then, so for those of you that haven't done databases, we'll go through some quick terminology here. At a high level, we talk about databases being some sort of structured set of data. We talk about a schema, which is kind of how all of these tables and rows and things relate to each other. It's kind of the view of the structure within our database. The actual data is stored in a table, and SQL is our language to interact with it. Is everyone familiar with these? Has anyone not dealt with databases before, and this is kind of new and special? Anybody? This is kind of your standard speak, a subset of the wording you use. In the course of this presentation, I'm going to be using an example database in MySQL. You can find example databases everywhere. This one's called Tequila. It has a schema that is a subset of the schema, but has separate tables. In this case, we have a films table, a list of films. One of them is called Academy Dinosaur. It's made up list of films and not real movies. Unfortunate, I know. And we also have other tables for actors, so lists of actors that might have worked on those films, and then a table that relates those films together. So this schema view helps us see what data is within each of these tables, how are those tables potentially related, and then ultimately we can start making SQL queries kind of based on this type of structure knowledge. So again, this is a subset of a specific database. The VIs and examples I will show today are based on these few tables and pulling them together and getting data. Any questions about this so far? Okay. Often, it's really convenient to have a database viewer. I personally use something called HeidiSQL, which is an open source viewer. Does anyone use HeidiSQL? One person? What do you think of it?
Does what it needs to do.
Does what it needs to do. I find it incredibly useful. Normally, databases will have their own viewer you can use. It's basically just an easy way to interact with the database, make SQL calls, look at what's physically in the database, potentially modify structure, add tables, do fun things. So if we use HeidiSQL to access our Tequila database, and look at a specific table of data, we see here's our database, here's our table, and here's a list of actors in this case. So Penelope Guinness is one of our example actors. And all of a sudden, we have an easy way to see what's in our database, what might be some of that data look like, or that. So, this doesn't have to be HeidiSQL. This could be, MySQL Workbench. This could be Microsoft Access. This could be anything. It's just really important to have an easy way to connect and make queries. Yeah.
In the name of nomenclature and whatnot, I guess it would be good to differentiate that it's not rows and columns as much in tables as fields and records.
Yeah, fields and records. I mean, most of this I'll talk about rows and columns, but yeah, these are our specific records and they have specific field definitions. There's a lot of terminology I just can't go into for this type of introduction. Basically, it's an Excel sheet that's way better than that. Not actually an Excel sheet at all.
Excel, but there's a terrible way of talking.
Yeah. Well, that's what people usually understand. If you haven't heard of databases, that's the easiest way to get you to thinking about it, even though it's a terrible way to think about it. So anyway, this tool also lets us write queries. So we might have a SQL query that selects from actors. Select all the data from the actor table, which we saw previously, and then this result of the query is 4 by 200, which is the same list that we saw in the actor table here. So we're just kind of pulling all the data from the table. So all of a sudden, our tool lets us look at the data as well as make a query for the data. That's all of SQL right there. That's all you do. Just make queries and pull data. Now, typically, my experience with making applications is that you first have to figure out how you need to pull your data from the database. Usually, you're not designing it yourself. Usually, it's already set up in a specific structure from a database architect. So you figure out what data you need to pull, and usually you use these external tools to make those SQL calls first. You can start them in LabVIEW, but it's much harder to kind of develop your SQL queries to be correct if you're doing it within LabVIEW versus with doing it in an external tool that can easily run and change the query and make sure it works properly. And then once you have the query working properly, you can pull that into your actual LabVIEW API for your database and then implement it there. Questions about that? Makes sense, and I'm sure most of you have done this type of thing. Some people I talk to only use the LabVIEW API. They don't have any sort of third-party tool that directly lets you write queries. And being able to do this really saves you time. So making your queries work outside of LabVIEW before you pull it in really make your life easier.
So some questions was, what tool did you use to create the diagram that you showed a couple of slides
The
ago?
diagram here is MySQL Workbench's native viewer. So if you look at this example database, it has a MDB file, some specific schema file that lets you pull this up in MySQL. And again, this is specific to MySQL. You could be using any other database. This is pretty common. Any other questions?
Are we able to get a copy of the database to play with?
Yeah, it's available here. Oops. Here.
Okay. So basically Google Tequila.
Google Tequila, it'll be the first result. And you can just download off the page. It's not as usable as some other example databases because you have to have an instance of MySQL to put it onto. So there's some some work you have to do to get up and running. But other than that, it's fairly usable. And my code and my slides will be available from this if you want to see any of that.
Okay.
Anyway, moving forward. When we actually look at SQL queries, these can be very simple from our previous example of our select from film. Every query has at least usually 3 specific keywords. The select, well actually let's start from. The from tells you what table is the data coming from. So in all these queries, they're pulling data from the film table. If this was actors, we'd be pulling data from the actor table. It just basically says, where is this data coming from? It's pretty readable and understandable. The where says, under what conditions do we want that data? In this case, we're only grabbing results where the title of our film is Academy Dinosaur. So we're filtering our results. And the select is basically how you want to format your results. This wildcard star just grabs everything, shows everything from the table, whereas these specific fields are only grabbing certain subsets of the tables. And that's an SQL query, a very basic one. Now, it's probably uncommon that your SQL queries are going to be this simple. So you're probably going to see something more complex with joins, with some MySQL functions included. And a lot of this presentation comes down to not being afraid of making SQL queries to do what you want to do in the database, rather than doing that work within LabVIEW. So this is an example of a query that uses MySQL functions to concatenate the first name with the last name. Instead of just returning the first name and the last name and then doing that yourself, MySQL will take the first name, add a space, and add the last name, and return it to a single row of data, a single column of data. We're going to join on the table that relates films to actors, then join on actors so that we get a list of actors as well as the list of movies. Has anyone used joins before? Okay. I don't really explain joins, but if you're using databases, joins are key to understanding and using them effectively. Joins are how you pull everything together within your database. So key points here. I don't want people to be afraid of SQL because if you're avoiding it, you're probably leaving a lot of performance on the table, a lot of usability on the table. It's fairly readable, as I've shown, and there's tons of tools online for learning how to do this stuff. So if you ever need to interface with the database, delve into the SQL, don't be afraid of it, figure out how to write your queries, and your life will be much easier than if you try to avoid that. The actual syntax for your database might vary depending on what engine you're using, but typically it's very straightforward. It's very consistent across these different database engines. It's only on the edge cases where you're using some special features of a given database that you might have some specialized implementation of it. So what we're seeing here in these queries is pretty much universal for any database that you're going to be using. And then finally, as we said, if you develop your queries, make them work in an external tool first before you bring them into LabVIEW. It'll save you some development. Questions? How do we actually do this? Well, there's lots of different ways. My examples are going to use the LabVIEW database connectivity toolkit. But the way I'm going to show you them is going to kind of abstract the API away from you. It doesn't really matter what you're using. interact with your database. And indeed, this is going to be determined by what your application needs. Some of these only run on Windows, like the Database Connectivity Toolkit, but if you're running on RT, you have to consider different packages. So here's a list that I found in the community. People specifically mentioned the Sapphire MySQL toolkit that I've used a precursor to this in the past. It's pretty good. And I've used the Database Connectivity Toolkit a lot. But generally, whatever connectivity option you're using is kind of secondary to how you actually develop your SQL code. These just enable you to communicate with that in LabVIEW. That's important, but you have to be aware of how to do it. Does anyone use any of the other options here? Like the Cassandra maybe, or the back one? Yeah?
I've tested most of them just because I'm on the Tools Network.
So you're the guy that's certifying these packages.
Pretty much. You are the Tools Network. Blame me for that.
Well, presumably they work because you tested them. So
No.
I haven't had much opportunity to use many of these except for, I guess, the SQL. Because I had a previous version of the Sapphire one. When you look at some of the examples in the Database Connectivity Toolkit, you see things like this. Now, do you guys see any SQL on this diagram?
Oh.
This is a trend. When you look at these VIs, they don't give you any actual SQL. They do weird things with the index and the column names, and they pull a lot of things, and it gets your data and it works, but you don't really know what's going on. And this trend is stated in the summary for the Database Connectivity Toolkit, and it basically says, this can abstract away the SQL from you and make your life easy to interface with databases. And what I want to say is that, maybe if you're doing a simple query, that type of abstraction from SQL can work. But for real applications, you probably need the actual full power of an SQL query, the ability to do joins, the ability to leverage MySQL native functions and the equivalent type of things to make your life easier, to reduce the amount of code you need in LabVIEW, and make the database do all that work for you. And it's a huge pitfall because people see these simple examples and they try to build their whole application from simple examples. And as soon as they need to do something complex, they don't have the tools to do that. So I hate the fact that most of our examples are so basic and hide SQL from you. And in fact, my function that makes a simple query in, result out, is a whole bunch of these Database Connectivity Toolkit VIs just to achieve that simple operation.
Just one thing there. I do think that you still, I guess the intention was right. You don't want to have a query that you are doing in multiple places. You don't want that SQL text string to be copied in different VIs.
Right, you should have a single VI.
You should have a sub VI that does that.
Right.
So you're not saying do not abstract.
I'm saying don't abstract away your queries. Write VIs to write those queries directly to do what you want. And we'll get into this. I have a pretty cool example here. So
The
this
difference between abstraction and obfuscation.
Yes.
right.
And you're making the argument that all we're accomplishing is obfuscation.
Yeah, we're obfuscating the actual interface to the database and making it harder to actually effectively use it for large applications. So this is the API I always want. I want an input of a string, some SQL statement, into a function. Now, this function could have references for the connection, but basically you have a string input and an array of string output, something like that, for your actual result of the query. Query in, data out. That's it. That's all your API really needs. Now, there's some APIs that make this more fancy and let you do all sorts of cool things with clusters and automatic formatting, but at its core, do SQL, this is all you really need. That's it. Is this simpler than the Database Connectivity Toolkit?
Doesn't the Database Connectivity Toolkit allow you to do that, though?
I am using the Database Connectivity Toolkit within this, but it's like 8 VIs for this one operation, so it's a little bit not user-friendly. And my idea here is that this query VI, now in this case it's a functional global, which is messy but functional for example, this query VI would represent any of the APIs that I mentioned previously. It doesn't have to be the Database Connectivity Toolkit. This pattern will work with any database interaction where you want SQL in, data out.
And your abstraction there is that sub VI is called get all films.
This specific sub VI is get all films. So if you wanted a function to get all the films in our database, this would do it. And it would format it nicely into a typed cluster and return it as an array.
Which also means that if you decide to switch and not use the Database Connectivity Toolkit, but use the Sapphire, you only have to go to a single
and actually the Sapphire toolkit provides a VI very much like this. You can plug, you can pop out that notation. Yes?
Now, the downside is that because you're going through this generic string and you're bringing the data back, you're getting it all as strings, and you're responsible for parsing it, for translating it, and everything else, whereas the ones that get rid of the minus the SQL directly and actually go through an API, you bring in the data in SQL, parse the cluster, compile it, and actually repeat it.
And there are some examples of toolkits that let you pass the cluster in as a type, and it auto formats all the data into that.
Right.
But the database connectivity toolkit doesn't do that.
No, but there are others that later came along and followed that pattern.
Those are really cool. I've used them for some SQLite stuff.
But that's one of the strong reasons why you sometimes say, actually, we do want to step away from MySQL because it is a generic database.
You can step away from MySQL from the format. Cool. Okay. So the other API function we might want is to get actors for a specific film. So this is using joins to relate what actors work on a specific film, and we're going to, based on a specific film title, we're going to get a list of actors for that film. I'll comment more about this in a second later on, but you should be a little bit afraid of this. But I'll deal with that later. So for now, just ignore the. If you see the pain here, ignore it for a second. So at this point, we hit a position where, say, our developer wants another call that gets kind of an aggregate data for both of these. We want a function that gets all the films and all the actors for those films in one go. Well, we already have an API that has get all films and get all actors. And if you didn't want to write any SQL, and you wanted a function that returned all films and all actors, how could you write that function?
So, right.
Get all the films and then get all the actors, then loop, get all the actors.
Get all the films, loop, get all the actors, right? Woohoo! Is this good?
I mean, what's your definition of good?
No, it's not good.
Okay, so sometimes, if you're doing this hardware stuff, and you have basic DLL calls, you have to iterate over inputs and get outputs and aggregate this stuff. However, if you're ever dealing with a database and you see this, you should think, no, please, this is terrible. Because what actually is happening here is we're getting a 1,000 element array. This is already one SQL call here. And then we're executing 1,000 SQL calls to get a little bit of data in addition to that initial data that we got and aggregating it out to the result. I have seen lots of internal tools that do this for worst cases where it's a double for loop, and they make independent SQL calls at each step and then use LabVIEW to analyze the data and bring it all to where
So
they
this is equivalent to a guy I was teaching once LabVIEW, and I was talking about for loops and while loops, and he was like all frustrated. And I said, I thought you said you have programming MATLAB. And he's like, yes. So how do you do something that needs to be repeated 10 times? I copy and paste. And I'm like, and if it has to be repeated 100 times, I number with the comments 1, 2, 3, and copy and paste. So basically that's what you, instead of using the power of the query.
Right. Yeah, now sometimes this is okay if it's not a for loop and you're just kind of aggregating. It's just a few calls, and it's not called very much, and your database is local, and it's not that far away. Maybe it's fine. And on the case of this VI, it actually runs in, a second or two on my local machine to a local database. But say you were working from home one day, and you were VPN into work, and the database was at work, and all of a sudden you have 100 milliseconds of latency between you and the database, and you make 1,001 SQL calls to the database. How long is this VI going to take? It's going to take eons. And usability time. So basically, this pattern is where when you're dealing with databases, you should think, I want to use SQL to natively get all of these things in one SQL call. Instead of aggregating existing function calls, use SQL features to do this much more efficiently.
So I don't know if you're going to go with this, but Ravi's saying, use stored procedures. So,
Stored procedures can do the same thing. Ultimately, it's basically the same SQL call. It might be written in a string constant like here, or it might be stored in the database. But yeah, that's the way to do it. Basically, you need one SQL block of logic that returns the data you want in one shot. So summarize, the pros here, of course, you don't have to make a new SQL query, but the cons is its performance is terrible. Long-term maintenance is really miserable with this stuff. You should be identifying where you need to make a new SQL call when you're doing this type of iteration versus where you can just aggregate a few results. Okay. And this is the summary of the database connectivity toolkit. Is one of the items is not having to perform structured query language programming is literally listed on the database connectivity toolkit feature. And as I said, for simple things that might be okay, but as soon as you hit the guy that needs to do the for loop iteration, that tends to fall on its face. You can't represent the actual query you need with that abstraction. And typically, if you're doing interaction with databases, you should be trying to use the full SQL capabilities to make your life easy. Now, we have a function call now that is not that great. So to optimize this, we need to identify what we need to fix. It's pretty simple in our case. If you have an application with thousands of SQL calls, you can profile them, see which one's being called the most, see which one's taking the most time. Typical performance type of considerations to figure out what you need to optimize. And then, when possible, you want to refactor those calls into a single SQL call. So this might be how you do it. We have the same things we're pulling out. We're using some SQL functions, group concatenate and concatenate. And this is actually the result of several iterations of improvement. This isn't just the first thing you would do. This is the several iterations of improvement on the SQL calls ultimately spit out a list of all films and actors. This is one SQL call that gets exactly the same data as the previous for loop implementation. So I have this in LabVIEW I can show you. So our get all films and actors VI firstly was this. If I run this, you'll see it, you can visibly see it counting up. Now, showing the indicator slows it down, but it doesn't slow it down quite as much as physically having this for loop over it. So the first thing to improve this would be going to one call here. And if I run this, it's iterating through different things. Now, so the first thing I did was I changed the SQL query from, I put it into a single SQL query. Here. Now, to show you some of the other tools we're talking about here, I'll put this in Heidi SQL. So here's our database, here's Tequila, and I'll put the same query into this, and I can execute this query and get the rows out. So the first thing I did when I rewrote this call is I figured out how to join the tables together to get all the data I wanted. However, what happened was an interesting thing where to get a list of actors, I had to do a join, but there were multiple actors for a single film. In this case, I just said, okay, well, whatever, I'll just copy, I'll just join wherever there's a match. So I'm going to get the copied information over here. We see, a bunch of rows that have a cat and a dinosaur. All of this is duplicate data. However, on the far right, we see different film actors for those different films. And when you have that coming into LabVIEW, you have to do an implementation where you do this kind of fancy search your index to see if it's already in your list. If it's not, we will add the film and actors to it, and if it is, we will add the list of actors because the rest of the information is duplicate. You get this kind of complex parsing. So it's still better because we have one query, but we still have extra rows because we see that over here we have a list of 5,465 rows from the return when we only have 1,000 films. And all that extra is just from these duplicate names over here. So the next step to make this better might be to use additional SQL functions like group concatenate, which uses more fancy things, where we're actually grouping by the film, and we're using a group concat on that list of actors with a specific separator to return the list very more succinctly. So if we compare this call that we initially had to this call, you see that it's pretty much the same thing, except that we're grouping by a film ID and we're using another function. And the return of this is 8 by 1,000 instead of 8 by 5,000. So this is a kind of an example of where you might take something that takes thousands of queries, make it into one query, but that one query still isn't quite as performant as you might need, and you might identify additional functions you could put into that to be better. So, questions about the full? I went through it a little bit fast.
So I'll run the results.
Yeah. So it's a comma separated list of actor names.
I think I want to read those full descriptions.
Some of these film descriptions are pretty fun.
Yeah, the one of the scientist with a teacher.
A astounding reflection of a lumberjack in a car who must think a lumberjack in a balloon factory. These are your standard kind of garble joke descriptions.
So here's another one from Robbie. He says that this is where views shine. Any change to any tables there and corresponding change to the view will be transparent to the LabVIEW code.
Yes, I will mention views in a second. That's a great point. Okay, so other questions, comments, thoughts about flow?
Kind of about something else to talk about. That one single VI that you use.
Yes.
Is that something that's available on?
It's available in my example here. So if we look at a VI, this VI is first a functional global variable level. So this is the gross, maintain a connection. I wouldn't recommend this for an actual application. I would probably pass around these references so you can have multiple connections if needed. But the actual useful bit is this one, which is what you need to wrap the database connectivity toolkit in to get those query and result types.
I guess my question is, like this VI that you have, is that shareable and like?
I can, yeah, if you want it, I can send it to you.
Okay, but
It's just my example for this thing. I put this together for my convenience.
Okay.
Because I hated having to call 6 blocks. I mean, it's just a sub VI, right, that you wanted to use.
I thought it meant in one of your like SE packages or whatever.
It's not an SE package. Fortunately.
One of the database examples has a code section that was published identically to that, the one that lets you do the SQL query as opposed to you.
I haven't seen that example because most of them I've just looked at and they're just miserable. So it's kind of sad.
Miserable. You cleaned them up.
You cleaned them up? Okay, maybe I'm just thinking of old before cleanup.
Yeah, remember he did a big effort in cleaning up examples in 2015.
It's true. Examples are way better in 2015. I will absolutely agree with that. I might not looked at that.
Yeah, nobody notices. I mean, spend all this time is that people are like, oh, the examples are ugly. They're not ugly anymore.
It gives me a better talking point. This sucks, so I made it better, versus this is great, so I made it slightly better.
That example is also in the documentation for the database connectivity toolkit. It's, at the beginning, they show you how to use your like normal cracked VIs,
Yeah.
and at the end, it actually tells you if you want to
Use the
build
queries.
like, I think it even says recommended to if you're going to be doing more complex queries to use the method.
Yeah, to use the more complex. Anyway, so to summarize,
Because you do lose something if you go that route, because when he builds the query, it's already parsed, so if you're going to make repeated calls, you actually want to pull that reference out. You can use it multiple times.
and I'll show that as well here, actually. So to summarize, before we hit a few slightly more advanced topics, the database can do lots of formatting for you that you otherwise would be doing in LabVIEW, and it's not just the stuff I showed with string concatenation. You can do addition, subtraction, timestamp, math, all sorts of crazy stuff to really save you time. So you really want to try to design your queries to do what you need in one single SQL call, try to make that as performant as possible, to make LabVIEW have to do as little as possible with your specific results. That's where life is very good. And sometimes even the queries themselves can be slow, and you can do things to make those queries faster. There's profiling tools and stuff like that. However, I want to bounce all the way back to this guy. Is this safe? Why, I'm seeing people shaking their heads. Why is it safe? What's the risk with this specific method?
Yeah,
You don't know what the string is going to be.
You can do SQL injection and screw up your database.
Yeah.
Exactly. Note how our query and our specific data we're passing with the film title are ultimately passed as a single string. And if there was, say, a single quote drop tables in our film title, it would potentially inject something into our SQL query and then affect our database as a whole, versus just returning a list of actor names. This is a common pattern. Who has done this to fix this issue? Yeah?
And something more complex than that, actually.
More complex than this, right? There's always a way to escape the escapement you're doing. This is common. It's called escaping your thing. So whenever you say have a single quote, you'll escape that. Reasonably, for most applications, this is fine. You usually trust your users to some degree. If you're making a web application, you probably can't trust this at all. There's things called like fuzzy logic loops that will take these string inputs and find some complex mix of characters that will always escape your specific escape logic. So if you actually need to protect yourself from SQL injection, you shouldn't be doing your queries like this. Okay? You should be doing parameterized queries. Has anyone done parameterized queries? Some people. Parameterized queries are an idea where you send the SQL query separately from the data that you're formatting into it. So that no matter what happens with your data, the SQL query is always the same. And this basically protects those data fields from not changing what the query specifically is. And if you're doing string formatting like this, formatting data into that ends up being your attack vector. So in my case, here's an example of using a parameterized query with my specific API. In this case, note how the quote %s quote has been replaced with a question mark. This is the flag, so this is a specific parameter that goes into my query. And my parameter is passed separately. So now when this physically is passed to the database, it sends the query and it sends the data, and it's not formatted before. The database does all that work, and it knows that the query is this specific structure of query, never can change. So it doesn't matter what's in here. You don't have to sanitize it. You don't have to do any of that pain. It just works. So this is, if you're doing inserts or if you're doing queries or filters that need to do string formatting, this is a much better way to do it. And indeed, if you're doing inserts, you can also use parameterized queries where you send it the query you have and then update the parameters each time so that the actual query you have doesn't need to change. It just stays the same and you can reuse that reference. So there's a lot of different cases where parameterized queries are your friend and they help you. Yes?
Can you show how you would do that in your database tool you got?
So we have parameterized. So here's that same VI. My FGV just does this crappy little checks if there's anything right, and I call it the parameterized. So this looks pretty similar. It's the same database connectivity toolkit VIs. There's a single one for create parameterized query, and it passes the parameters in.
So, but in your other tool that was it
Oh, how you do parameterized queries there?
Yeah.
You can't.
Okay.
So there's a little bit of pain, like if you have a specific query and you want to, check if this works in Heidi, what you typically do is you put it in a new query tab, and you kind of have to say, well, I have to put some real data in here. So I have to say academy time.
That's your favorite.
That's the first move, guys. Don't let her remember. So you kind of have to fill in your fields, your parameters manually in this tool. I think other tools probably have different features, but this is actually a common complaint when you're trying to verify parameterized queries, is that you have to fill in specific things when you verify that it works, and then you have to replace those with those question mark wildcards later on.
So one of the things that we've done, even though it really, to be a unit test, you should not be testing connected to the actual database. But when we work with databases, we do have a battery of unit tests that do connect to the database and test for those things. So
That's for specific sets of data that are supposed to be there. You can even insert your table and test that it comes back.
Exactly.
Yeah.
So anytime you're doing a basic, like even the first one that you need to get all filled, there will be a unit test for that query. So if things change in the future, you're reminded about
You
it.
could also run a local database instance and provide different connection information to your application and just lots of different. If you haven't seen parameterized queries, there'll be an answer to a lot of problems with injection. But you probably have. I hope you have if you're doing big database stuff. So, don't name your kid drop table.
No, don't name your kid drop.
Or null, and that's actually a name.
Null. Yeah. There's stories about how people's name was null and it wasn't passed right. It became just something in the database and they had to change the out.
So I was trying to find it, but I don't remember the magic Google search for things developers don't test for, and that are those types of things. So things that you have to test for is weird characters and stuff like that.
Weird characters, a lot of injection attacks that use Unicode characters for single quotes that you don't check.
So I was going to ask you, do you talk about using UTF-8, the conversion to UTF-8?
LabVIEW support for that is somewhat working. Not really official, doesn't really work sometimes.
Yeah, the LVI is actually hidden.
Yeah.
If you're using Sapphire's toolkit, they have it, and you don't have to be reinventing the wheel because it escapes most of the characters.
Well, if you're worried about escaping, you should use parameterized queries.
Yeah, no, but even your parameterized queries, if you're doing a note field, and they put enters and O'Donnell.
Doesn't matter. If it's a parameterized query, it doesn't matter because that data is parsed separately from the query. So you don't have, it could be all sorts of crazy stuff in there. It'll go to the database properly because the database gets it. It really is. So I just have a couple more points here. One of them is explain. This is something that you put before your query in HeidiSQL. So I'll show you what this looks like. If we look at the query that was expensive, the one that had all the rows, 5,000 rows. If we wanted to see kind of why this was taking a long time, if it was, or something you could explain before it, and I expect most engines have this type of behavior with a keyword. And instead of returning the data, it returns an analysis of this query. In this case, you can look at the documentation in your case, but basically the join is simple in all of these. The table is fine. The type of join is also pretty decent. Basically what you do is you look at the return of this analysis, and sometimes it says it's not an index or it's a string equivalence and it's a copy join, and this is why your query is slow. So if you're ever trying to figure out why a specific query that you have takes 5 seconds to execute, this is some of the profiling you might do to try to understand that. I've seen cases where I was doing a join on a numeric column on another table, but since the initial column wasn't a key row, didn't have a key associated with it, it took forever because it had to specifically pull that row out and make it joinable and slow. But as soon as they updated this actual structure of the database for that to be a key, it operated in a second instead of 30 seconds. So this type of database profiling is honestly more just how do I do databases. But if you have a slow query, knowing that there's profiling tools and trying to see how long these things take is ways to kind of figure out how to do it better. This query is good though because it's joining all the rows, not that bad, but it's still going on different primary keys and things that are quick to connect together. Yes, 5 minutes. You also might have a view. So who mentioned views?
Ravi.
Ravi did?
Yeah, from Detroit.
So a view might be a way to take a way you're pulling multiple tables together, do it in the database, so that instead of having to query and do all the joins in your SQL code, in your LabVIEW code, you can make the database do that work, and then you can query this view as if it was a table. So to give you a specific example here, our database actually has a view already, and this is part of the example, but it's film list, I think. Yeah, so this film list has the title, the description, the category, basically the information that we were looking at before, as well as a list of comma-separated actors. And this view is defined by SQL. In this case, it's complex and it does all sorts of stuff I'm not going to talk about. But essentially, this is the same as the query we made that pulls all that data together in one result. However, since this is now a view in the database, we don't need to do all the joins if we want to get data from it. So if we looked at this in our API, we might have get all films and actors from the view. And this implementation gets pretty much all the same data. But now our query is as simple as you could possibly imagine. But it still returns the same information pretty much that we got before. So if you find yourself doing these types of join queries a lot, and you represent it consistently, using a view to get that data might be a way to put that work into the database, make your queries. What?
What films are we missing there?
What films are we missing?
Yeah, you got 995.
Oh, so the way this view works is I think it doesn't include films with no actors on them, whereas my query included films with no actors on them. I don't know if it's trying to say that those films were not out yet or something. I don't know what the logic is, but I think there's 4 films that have no actors, so the way this view is like
They're nature documents.
the nature document.
Stop motion animation.
Yeah.
So, another question here, tangentially related question from Drew.
Uh-huh.
It says, how do people use SQL databases in a data acquisition application? I can see the benefit in storing relational metadata, customer tests, experience under tests, but storing actual data doesn't seem appropriate. People store TDMS files as blobs or file paths to a TDMS file, etc.
I would say if you're doing TDMS analysis, it's kind of separate. This might be more of, it depends on what your application is.
Yeah, but basically what he's saying is you acquire 1 gigabyte worth of waveform data at a test.
So some people will take each reading and store it in a table, like data results. And the database will be set up so that it can handle that. It can have a gig table and it's fine. It's probably much less common to store a TDMS file as a blob in the database because then what they use the database for? What's the point? Yeah?
So, I don't know, 8, 9 years ago, the company I was working for had our own version of database and database analysis tools from LabVIEW into the database. And we had been doing some things where the customer was doing, 100,000 or million sample per second type acquisitions and putting it into tables, and performance was horrible. But really what they needed at the time was they needed some of the summary measurements like an FFT. That we would store the results in the table, but then we didn't support blobs at the time and added the ability to support blobs so we could dump that large data set in.
Just have an array.
They needed to retrieve it and do further analysis on it because the databases were not handling multi-100 million or more row tables very well.
Summary statistics make sense. It's even like when you talk about now where you're pushing analysis to the edge, where it takes a huge amount of data, summarizes it into some sort of set of points you care about, and then that's what gets stored. You can still use TDMS as like a log history of that stuff, and there's actually some tools with DDM that you can use to analyze that. But
So I think that the generic question for me to ask this is, what options exist for queries with large data set returns? Because he says that the ODBC drivers dynamically allocate memory, and that slows down large queries. So running the same query in a database viewer, you see it run really fast, but then when you do it on the computer, it's not.
I pulled a lot of data through the database connectivity toolkit, and it's been pretty good. I know you can multi-thread it. If your database supports multiple connections, then you call multiple instances of it. Somebody in my NIW presentation was talking about that, how they're running our thread pools with .NET. There's also some other pain, but they were able to call multiple things. So I don't think the data throughput of the ODBC should be I think you should be able to pull a lot of data in pretty quickly, but I haven't done it too much.
Okay.
Yeah, and there's other, like, honestly, if you're hitting it, if you can identify the issue as part of the API you're using, maybe try the other APIs that provide high performance.
And then Tim Robinson is saying that in Microsoft SQL Server, you can store the data as a special link to a file, stream.
It's probably like a link to a network share or something.
There's also some specialized queries where you can retrieve large sets of data that are specific to the different languages or the different flavors of MySQL or SQL. You can also do bulk inserts, bulk queries. There's tricks.
Yeah, and so we mentioned stored procedures, stored functions. There's other things you can do that preload these queries into the database and you call into them. But at this point, this is all the content I have, and all this kind of turns into how do I database and all sorts of SQL stuff. So, yeah, any other questions?
Is there a group or a specific forum at NI.com for database stuff?
Not that I know of. There might be a toolkit forum, database connectivity toolkit forum. I'm not. If anything, there's that, but I honestly don't.
I searched for it before, and I don't think I found
Didn't find it?
relevant. Yeah.
You can post in the LabVIEW forum, maybe get help.
Yeah.
Email me, and I'll take you to support. Maybe I'll help you.
So you'll add the slides to the.
Yeah, actually, the slides are already available.
Just put a link on the.
I can put a link to them because this is the same as my week one. There's
That's
even a
only
recording there.
available to, you only did it on Wednesday, right?
And on week.
Oh, you did it on Wednesday?
Yeah.
Okay, so it'll be general.
There's a forum page with it. I'm assuming
Yeah.
anyone can see that.
Yes.
And I can post the code as well
Yeah.
if you guys want. Yes.
I learned a lot of way to optimize my current code, but assuming it's still slow, the way we have it set up is computer in our lab that is accessed by user in Armenian, which could cause lots of problems. Any suggestions on ways to move a database to the cloud or something like that?
So typically what you're looking at is distributing the database in multiple places that are then mirrored back to each other. This is all sorts of database architecture stuff, but you might have a master that has multiple slaves in different areas. Like you might actually have a server in Armenia that replicates back to your database here at Green. If you're looking at that, probably what you can do, this is computer science land. There's people that do this all day for their job. So I don't have a great answer for you, but the answer probably is locate in the database as close to the locations and then managing replication back and forth between them. If you actually need him to have fast query access.
Right.
Amazon Cloud Web Service.
What's that?
Amazon Cloud Web Service.
Yeah, there's two services out there that you can hire.
There's-
Different cloud databases you have access to.
Any ideas on what those are, or just Google search?
I mean,
Okay.
choose your database, and then you'll find 50
Yeah.
providers for it. It's everywhere these days. And the database needs, most applications are well under what you do with websites, right? The back end of websites is crazy performance. They have those distributed all across the world for the database backend. It's all sorts of cool stuff. So,
I do know if you're like building Apple like OS apps or live or something like that, database cloud where you can actually
Okay,
similar things like that.
right.
you can even just send them like backup and store locally. There's even copy ways you can do it like that. But, yeah.
Currently, it's like, what takes us, a second or two to access the database is like 5 minutes query for it. Now, obviously, there's a lot of
It might be
optimization.
thousands of queries in the latency
Yeah,
that causes that. Yeah.
There's a lot of optimization that can be done, but the next step would be
That, Q3 in the middle, is that a primitive or is that a SWI?
That's a database variant 2.
Yeah,
Data.
data.
It's an Xnode, actually.
It is an Xnode, yes. It's like the variant to data, but it's the database version of that.
Can it actually adapt the type and give you a cluster output, or array of cluster output?
Yeah, sometimes.
Yeah, the difference between that thing and variant data is that thing handles null fields slightly differently than variant data does. That's really the only difference.
Yeah. So in this case, I'm just turning the array of variants into an array of strings because it's more convenient for me to parse. You might leave it as an array of variants.
If you do use that, then be careful when you're doing timestamps and stuff like that, because different databases have different timestamp formats that don't exactly match our LabVIEW timestamp.
Yeah. Your format into string and format from string and scan from string with timestamp format specifiers is your friend, because you can have a single format string that pulls it into the correct LabVIEW timestamp if you do it right, instead of having like 50 timestamps.
Yeah.
And if you're doing timestamps in databases, there's lots of database functions like timestamp diff that lets you do the math in the database. The most egregious example of this I've seen is where somebody pulled out all of the time logs in individual fields and then used LabVIEW to aggregate the actual time spent. And it was like 10,000 SQL calls per specific project that had to be done to get the reporting data. And then I wrote it for my own analysis purposes into a single SQL call that did all timestamp diff logic, accounting for nulls, and it just returned a single hours log value. Way more efficient.
All right.
Leaving a lot of time.
Yeah.
Thanks, everyone.
All right, so 10-minute break.
Cool.
That's good.
If you want to learn SQL, this is a guide I saw recently that's amazing. So go there. It's just a random blog, but it's awesome. So, yeah.